look at graphs of quadratic functions. Remember, the formula for a quadratic function is y equals ax squared plus bx plus c, where a cannot equal 0. A is going to be the coefficient of the x squared, b is going to be the coefficient of the x, and c is going to be your constant. These graphs are going to graph as what we call parabolas. The parabolas will either open up or they'll open down. The opening depends on the value of the a, which is the coefficient of the x squared. If a is positive, the parabola will open up. If a is negative, the parabola will open down. Let's discuss some other parts to these parabolas. The parabolas have a point if they open up at the bottom, which will be a minimum point, more specifically called the vertex, and if the parabola opens down, it will have a maximum point at the top of the graph. Each parabola has what we call an axis of symmetry. The axis of symmetry goes straight through the vertex, and we'll chop the parabola into two equal pieces if folded on the axis of symmetry. Remember, for x-intercepts from elementary algebra, set y equal to 0 and solve for x. And for the y-intercept, you're going to set x equal to 0 and solve for y. Let's actually look at an example. Our first example will be y equals x squared minus 8x plus 12. Notice your a is 1, your b is negative 8, and your c is positive 12. We know from the a, since the a is greater than 0, this parabola will end up opening up and will have a minimum. Now, let's actually find the vertex. The vertex formula for the x is going to be the opposite of b divided by 2a. In this case, we're going to take the opposite of negative 8 and divide it by 2 times 1. You'll notice that's going to be a positive 8 on the top divided by 2, or our x-coordinate will be a 4. To find the y-coordinate, the formula says we take the function value of the negative b over 2a, which is just the function value of the x we just found. So we want to plug 4 into our function. That will be 4 squared minus 8 times 4 plus 12. That's going to be 16 minus 32 plus 12. A negative 16 plus 12 is going to give us the value of a negative 4. So our y-coordinate will be negative 4. The x-coordinate is going to be used in your axis of symmetry. X equals 4. Your y-coordinate is going to actually be your minimum. If you will plot positive 4, negative 4 on your graph, put a dotted line through x equals positive 4. That will be your axis of symmetry. Now we're going to need a little bit more information to graph by hand, so let's find the x-intercepts. We'll set y equal to 0 and solve. This one will factor nicely, but we can always fall back on that quadratic formula. This will factor into x minus 6 times x minus 2. Setting each piece equal to 0, we'll get x equals a positive 6 and x equals a positive 2. If you plot positive 6 and positive 2 on your x-axis, you will notice the relationship between these 2 points in the axis of symmetry. Each x-intercept is exactly 2 units from the axis of symmetry, so they mirror themselves. Now, let's find the y-intercept. For the y-intercept, we set x equal to 0, so 0 squared minus 8 times 0 plus 12. Notice the first 2 pieces will be just 0 plus 12 is going to give us 12. In a quadratic equation, when you're looking for the y-intercept will always be just the c, or the constant. Notice the constant, or 0, 12, is exactly 4 units from your axis of symmetry. So if we want to mirror that, we can come out an additional 4 units and put the corresponding point, which would be at the positive 8, 12. Now with these 5 points, we can connect, make the parabola with a smooth curve, arrows on both ends, and we have the parabola for our equation. Let's look at one more example. If y equals x squared minus 5x plus 6, the a equals 1, the b equals negative 5, the c equals 6. Since our a is greater than 0, we know that the parabola will open up, therefore having a minimum. Finding the vertex point for the x, we'll take the opposite of b over 2 times the a. The opposite of negative 5 divided by 2 times 1 will be a positive 5 over 2. So our x-coordinate is going to be the fraction 5/2. For the y-coordinate, we plug our x-coordinate into our function. So the function value of 5/2 is going to be 5/2 raised to the second power minus 5 times 5/2 plus 6. If you're uncomfortable working with a fraction, remember that your calculator will do this for you. In order to do this, let's type in parentheses 5 divided by 2, close parentheses, raised to the second power, minus our 5, times our 5/2, so 5 divided by 2, closing that parentheses, adding 6, and hitting equals. You'll notice that our value is negative 0.25. Since our first coordinate was in a fraction, let's make this one into a fraction too by hitting Math, enter, enter. And so we'll notice that our y value is going to be negative 1/4. Remember, your x value is used in your axis of symmetry. So x equals 5/2. Your y value is actually going to be the minimum of negative 1/4. Plotting that on the graph, 5/2 is 2.5, negative 1/4. Axis of symmetry is x equals the 5/2. We're needing to find the x and the y-intercepts. So x-intercept, if we set y equal to 0 and solve, again, this one will factor nicely. Remember, you can always fall back on that quadratic formula, but x minus 2 times x minus 3 will give us what we need, meaning our x-intercepts are going to be x equals 2 and x equals 3. If we plot those on our graph, each one of those is exactly 1/2 from that axis of symmetry. To find our y-intercept, we set x equal to 0, so y equals 0 squared minus 5 times 0 plus 6, or just y equals 6. Now, if we want to mirror that point from the y-axis to our axis of symmetry is 2.5 units. So if we come out another 2.5 units, we can plot the point of positive 5, positive 6. And again, this will give us ample points to draw the parabola. You can also graph these on your graphing calculator, and you'll get the exact same picture we're getting here. Let's work one more example. Y equals negative x squared plus 2x plus 8, where our a is negative 1, our b is 2, and our c is 8. Since the a is negative 1 and is less than 0, the parabola is going to open down. Therefore, we'll have a maximum. Let's find the vertex point. For the x, we're going to take the opposite of b divided by 2a. That's going to be the opposite of 2 divided by 2 times negative 1. Well, a negative 2 divided by a negative 2 is a positive 1. So our x value will be 1. To find our y value, we plug our x value into the function. So we're going to take the function value of 1, being the opposite of 1 squared plus 2 times 1 plus 8. That's going to be the opposite of 1 plus 2 plus 8. Negative 1 plus 2 is going to be 1 plus 8. Our y value will end up being 9. We can go ahead and plot our vertex of 1, 9 on our coordinate system. Your axis of symmetry is going to be x equals the value we just got for x, or x equals 1. So a dotted line through x equals 1. Our our maximum is going to be the y value of 9. Finding the x-intercepts to set y equal to 0 and solve. The first thing I'm going to do before I try to factor is factor out a negative 1. That'll make my leading term positive. So negative 1 times x squared minus 2x minus 8, which will factor into x minus 4 times x plus 2. That will give me an x-intercept at a positive 4 and an x-intercept at a negative 2. Let's plot that. X-intercept of positive 4, x-intercept of negative 2. Each one is 3 units from the axis of symmetry. Our y-intercept is always going to be the c, so in this case our y-intercept is going to be 8. 1 unit to the axis of symmetry, 1 more unit out to mirror. We have our 5 points, so we can draw our parabola. Now, let's actually do a little bit of review from what we just got. If they ask you for the range, remember the range is your y values. So it starts at negative infinity, and our highest y value is going to be 9. The range would be from negative infinity to 9. The graph is increasing. First, remember we use our x values. So since this continues to come down and out, we'll start at negative infinity. It stops increasing at this point right here, which is the x value of 1. Then the graph decreases, starting at 1, going to positive infinity. X values only, endpoints never included for increasing and decreasing.